Hello, everybody. This set of notes is going to cover 3.4, which is proving triangles are congruent by angle, side, angle, and angle, angle, side. In the last video, we talked about proving triangles congruent using side, 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 and side, angle, side. So this is just adding on two more ways to prove congruency. As a reminder from what we talked about in the last set of notes, in order to prove that triangles are congruent, you need 3 out of the 6 triangle pieces of information, right? Every triangle has 3 angles and 3 sides, but not every combination of those 3 things are used to be able to prove congruency. So for example, one of the things we talked about in the last set of notes was angle, angle, angle is not a way to prove congruency. So if you have those 3 things, you can't prove your triangles are congruent. So we are going to just be adding on to the things that do prove triangles are congruent, and that's going to be angle, side, angle, and angle, angle, side. So angle, side, angle says if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of a second triangle, then the 2 triangles are congruent. So here's a visual for you. I have a triangle and another one. And it says if you have, what is it? Which one is this? Angle, side, angle. Okay. So if you have an angle, a side, and another angle congruent to a side, an angle, a side, and another angle from a second triangle, then we can say that your triangles are congruent. The easiest way to look at this one is if all 3 pieces of information lie on the same line. Okay, notice that the side is strictly in between the 2 angles mentioned, okay? And the reason this is important is because angle, angle, side, which is the next one that we talk about, has the same 3 pieces of information. It has 2 angles and a side, but the side doesn't have to be included. So wherever that side is will determine whether or not you have angle, side, angle, or angle, angle, side. So angle, angle, side says if 2 angles and the non-included side of one triangle are congruent to 2 angles and the corresponding non-included side of a second triangle, then the 2 triangles are congruent. The visual for that would look something like this. Also, I apologize if you hear children screaming in the background. My children are doing something in the other room. Couldn't tell you what they're doing. Okay, so we still have the same 2 angles, but instead of this side being the congruent side, it could either be this side that is the congruent side, or it can be this side that is the congruent side. It doesn't really matter. It just cannot be the side that is in between the 2 given angles. So I'm just going to go for this one just because it's easier. Okay, so again, these 2 methods are very similar. It all just depends on where your side is located at. Okay, so now that we have those 2 new ways to show that triangles are congruent, we're going to list all of the ways that do show congruency. And that is side, side, side. Those are ugly S's. We have side, angle, side, where the angle has to be in between the 2 sides. We have angle, side, angle, where the side is between the 2 angles. And then we have the lovely angle, angle, side. So those are 4 ways that we can prove congruency. And then yesterday, or the last set of notes, we talked about 2 ways that do not prove congruency. And that is going to be side, side, angle, and angle, angle, angle. Now, I didn't mention this in the last set of notes, but the way that you can remember this word is it is a bad word spelled backwards. So just rearrange the letters, and if you see that word, that's a bad word, so it doesn't prove triangles are congruent. But that's why we don't say angle, side, side. We say side, side, angle, okay? And then angle, angle, angle is not a way to prove congruency because since you don't have any side information, there is no way for us to know if we have a big triangle and a small triangle together that just happen to have the same 3 angles. Okay, so kind of like what we did in the last set of notes, we're given 2 triangles and we have to determine if they're congruent, and if so, we need to state our reason, and then we need to complete the congruency statement. So when we look at these first 2 triangles here, there are 2 angles and a side, right? So we either have angle, side, angle, or we have angle, angle, side. Those are our 2 options. So if I were to highlight the side where the 2 angles are located, notice that the side is also there, meaning that this is going to be able to be proved congruent by angle, side, angle. So we would say, yes, angle, side, angle. And then we're starting at G, moving up to B, going down to H. So G is where that single arc is. So in my second triangle, I have to start where the single arc is. I went away from the side that's marked congruent in my first triangle. So I'm going to go away from the side that is not congruent. And then I go down to the double angle marker. So this will be congruent to triangle NPK. Looking at triangle 2, right now I have an angle and a side that are marked congruent. That is not enough information for me to prove congruency. I need one more piece of information. I can either grab a side if I know some information, or I can grab an angle. It just kind of depends on what information I'm looking for. I'm not given any information. Ooh, why did this not go all the way through? Weird. Okay. I'm not given any information. Like, it doesn't say given SN is congruent to NM. So because I'm not given any information, I have to look for something that can be true without given information. And for me, that's going to be our vertical angles. So now I have another angle. So this is either going to be angle side angle, or this is going to be angle angle side. And when you look at those two triangles, the side is not here. That would be angle side angle. So instead we have angle angle side. So we would say, yes, these triangles are congruent by angle angle side. Start at M, move up to N, over to P. So I'm going to start at T, move up to N, go over to S. T, N, S. All right, and then lastly, we have two sides that are already marked congruent. That is not enough for me to prove congruency, so I either need another side or an angle. And again, I'm not given any information anywhere on this picture, nor am I given it like off to the side. So the only thing that I can really look for is a reflexive property, or I can look for vertical angles, and lo and behold, I have vertical angles again. So because I have two sides and an angle, I either have side-side angle or I have side angle side. As a reminder, if you are looking for side angle side, you're going to mark the two lines that are congruent, and where they intersect is where that angle should be in order for you to have side angle side. That doesn't happen here, and so because of that, we have side angle, which is a bad word spelled backwards, so this is going to be a no. We can't prove congruency here. Sad face. And then remember, if we can't prove congruency, we cannot write a congruency statement. All right, we're going to just move on to some proofs. We're going to be able to now use angle side angle and angle angle side as another way to prove congruency. So here are our options: side, 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 angle, side, angle, side, angle, 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 side. Those are our four options here, okay? So we're going to always start with our given information. That's always where we start. So number one, we have line IG bisects angle FIH. I know that that's true because it was given to me. So here is angle FIH. Here's angle FIH. It's that big angle, okay? And it's being bisected by line IG, okay? As a reminder, when you have a large angle that is bisected, you get two smaller congruent angles. And as another reminder, when we are writing down our proofs, the whole goal of our proofs are to find those congruent parts. Do we have a congruent side? Do we have a congruent angle? That's what I need to be able to prove congruency, right? So this first statement here, IG bisects angle FIH, doesn't give me a congruency statement. It just tells me that I have an angle that's bisected. But if I have an angle that's bisected, I am able to conclude that angle 1 is congruent to angle 2, and that is angle information, which is important. Because I have angle, it's definitely not going to be side, side, side. Those are I now have 3 options instead of 4 options, okay? Now, I know that angle 1 is congruent to angle 2 because that is what happens with the definition of angle, of an angle bisector. And remember that these reasons are on your blueprint document that you have in your notes, okay? Now, we are going to move on. That's my first given. Now I'm going to move on to my second given, which is angle F is congruent to angle H. Got another piece of angle information. I know that that's true because it was given to me. So up in my picture, I'm going to mark angle F congruent to angle H. That is a secondary angle. So this isn't going to be side angle side because, again, I have 2 angles. So that leaves me with angle side angle or angle angle side. Okay, now I've run out of givens, so this is where we have to decide on what other things I can prove are congruent without a given. Your two typical options are going to be vertical angles or the reflexive property. And if you look at this picture, I don't have vertical angles, so my only option would be this reflexive property. So my fourth statement will be that IG is congruent to itself, and that is true because that's what the reflexive property is. Reflexive prop, and now I have a side. Now I will tell you that the order of these letters does not determine the way that you're proving congruency. So what do I mean by that? Just because I have my two angles first and the side does not automatically mean that I have angle side, because everybody can do their proofs a little bit differently. You really do need to look at the picture that you have marked up to see if your side is in between the angles or not. So don't look at this order here and determine that, ooh, automatically it's angle side, because it could be, but it could also be something else. So when you look at this picture over here, remember in order for it to be angle side angle, your side would need to be located there in between the two angles, which this one is not. So because of that, this one is going to be angle side. I have enough information to prove congruency at this point. So I can say that triangle FGI is congruent to triangle HGI, and that is true. Ooh, don't know how to number things. And that is true by the angle side method. Yay. All right, last one here. We're going to start with our givens. And my first given is that segment AB is congruent to segment DC. That is true because it was given to me, and that's already a side that I can mark congruent. So AB is congruent to DC. Yay. Next, I have that segment AB is parallel to segment DC. Ew. My letters are looking very not good. Okay, that's also given. Now, remember that my whole goal with these statements here is to prove congruency. And lines parallel doesn't give me a congruency statement. It just tells me that lines are parallel. But I've been asking you guys for a really long time, when you have parallel lines, what are you supposed to be looking for? And hopefully you're yelling through the YouTube right now, angle pairs. Yes, angle pairs. So we have some options here, okay? I am going to do what what my brain is telling me to do, but I will preface this by saying that this example actually has more than one way to prove your triangles are congruent. I am going to prove it using only one method because that's all I need, and then I will go back and explain the other way to do it. But just know that I'm only going to do one proof. As a side note, when we do proofs, we do not want to include extra information because we don't want to crowd our proof with unneeded information. So even though other things may be true that we could prove in here, if it doesn't help me get to my triangles being congruent, then I don't want it in the proof, okay? So since A and B are parallel, since line AB is parallel to DC, I'm looking for angle pairs. So I can go ahead and say that angle A is congruent to angle D. But what I can also say is that angle B is congruent to angle C, and I can mark both of those things true at the same time. So on line 3, I can say that angle A is congruent to angle D, and I can say that angle B is congruent to angle C. And that gives me 2 angles right off the bat. Well, you guys, that's 3 pieces of information. So I either have angle side angle or I have angle side. It just depends on where those things are located, okay? And this is where we have to say if lines parallel, then alternate, boop, 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 boop. Alternate interior angles are congruent. Okay, and that's enough. I'm done. I can say that these 2 triangles are congruent. AEB is congruent to triangle DEC. And when you look at your picture up there, you have angle side angle. Okay, so that is one way to prove that your triangles are congruent. Now, I'm going to do a little erasey, okay? And I'm going to do something a little bit different. Let's say that I just don't see or I don't really care to mention that B and C are congruent because that doesn't matter. At this point here, I don't have enough information to prove congruency. I have one side and one angle. However, my brain could say, ooh, angle 1 is congruent to angle 2. And I can say, ooh, okay, well, I'm gonna move you down. I'm gonna move you down. I could also then say that angle 1 is congruent to angle 2, and that reasoning would be vertical angles are congruent. And now that I have that, again, I have another angle, but where my angle is located changes things. Now I can prove that these two triangles are congruent by angle, angle, side. So this could be, ooh, angle, angle, side. And you'd want to obviously renumber your numbers. I'm not going to do that for this case. The other thing you can do is very similar to what we have here, but instead I could get rid of A and D, and I could say that B and C are the ones that are congruent. So I would just come over here and I would erase this and put B is congruent to C. The reason is still the same. If lines parallel, then alternate interior angles are congruent. I would have my vertical angles. You'd still have angle, angle, side. So I guess essentially right now there's like 3 different ways to prove congruency. So I do want to also let you know that like most of our proofs, like 99.9% of our proofs are only going to be able to be proven one way, but there may be a time like this case where you can prove your triangles are congruent in more than one method, just depending on what information you want to use. You do have to be careful though, because notice that as I had unneeded information, I was erasing it. You do not want to have unneeded information in your proofs, okay? But anyways, that is the general idea of proving triangles congruent by angle, angle, side, and angle, side, angle. As always, if you have any further questions, please go see your teachers during their normally scheduled tutorial times, and I will see you in the next video. Goodbye.